respectful of everyone's.
Yes.
It's a good idea.
All right, so everyone should be able to see our slides. Minimize this. So do you want to describe what's coming next?
Oh, yeah, we've got a couple of other webinars coming up that we just wanted to make sure you're aware of. In March, on March the 21st, we're doing a Your First Crowdsourcing project, which is about running crowdsourcing projects and a lot of the soft skills and approaches that we've seen be successful over the last decade or so of running projects. And then in April, we've got our friends from the University of Alabama who are using the GPT APIs to do a lot of metadata workflow pieces and experimenting with that. And I saw them present on this at the AI for LAM conference in November, and I thought that this crowd would also be interested in what they were doing and what they were learning. So you're invited to both of those. We'll drop the link into the chat here shortly. Oh, if we haven't already, we already have. Thanks, Anna. And so, yeah, let's get started.
Okay, so today we're going to start with some background on what handwritten text recognition is, how it's different from OCR or crowdsourced transcription, how good it is. Then once we're kind of done with that background, we're going to talk about the ways that we're integrating HTR technology into FromThePage. And then if you stick around through all of that, we're going to close with some of the AI hallucinations that we encountered during the process, which everybody enjoys AI hallucinations. So let's get going.
These are good ones too.
Yeah. All right, let's see. Okay, so let's start by talking about what HTR is. So most of us are familiar with OCR, optical character recognition. So this is a technology that's been around for decades. It looks at an image of a printed document and automatically transcribes the content of the document into electronic text, generally by looking at each character and matching that character against a database of what different other characters look like. So HTR is different from OCR. Why is that? First off, it's got challenges that OCR doesn't have. So letters are connected in many handwritten documents, cursive or joined up writing. That means that the software isn't able to isolate a single character to match against a database of similar characters, right? Instead, recognition has to be done word by word, which really complicates the problem. Another reason that HTR is different from OCR is that there are a lot more scripts and they vary a lot more than there are printed typefaces. Also, two people who've been taught the same cursive script may write very differently, right? So a clerk who writes professionally may write in a very different hand from a farmer who's just taking notes about crops that have been planted, even if they were taught the same script. And as an aside, hands can even vary with the same person over the course of the day. Laura Weekly at the Buffalo Bill papers talks about how Buffalo Bill's handwriting changes over the course of the day, depending on how much whiskey he had consumed. So there's a lot of variation here. So as a result, HTR software has to be trained on ground truth in ways that OCR software doesn't, right? We use OCR software generally, it just works out of the box. So the ground truth is human transcribed text that's matched to the images that it was transcribed from. The example on the right is an example of HTR software that was trained on ground truth that was produced from a British library project working with Arabic scientific manuscripts on FromThePage. They exported it, they trained a model. Now they have a model that's pretty good at doing HTR on Arabic. Another difference is that HTR software often has to be retrained and fine-tuned on a particular person's hand. That's almost never the case with OCR. Next slide. So HTR is also different from human transcription. There are obviously differences in process, right? Humans versus computers doing the work. But I want to talk about some very specific things. HTR output is like OCR output and different from human transcribed output in that it maps each transcribed word onto matching regions of the image. So the output of HTR engines generally includes the bounding boxes for each word describing the coordinates on the image that match the text that's being transcribed. So bounding box linking can be really powerful. This is what powers the full text search that we use that highlights matching keywords, and that could be in digitized newspapers or in PDF files, right? You've got this keyword highlighting. Very, very useful, and I think we've all used it. One of the challenges is that HTR engines don't differentiate between important text and unimportant text, unlike humans, right? So this is the HTR output from a diary entry. And you can see that in addition to the diarist's writing that is transcribed on the bottom two lines, it also transcribes the pre-printed information on each page. And some of that is useful, right? The month name and the date and stuff like that. But there's also these pre-printed notes about when pheasant hunting season ends, and I doubt that anyone reading the diary would care about that, and certainly no human transcribing this would be likely to transcribe this. The HTR system doesn't know which text is important and which text isn't, so it transcribes absolutely everything. Next slide. So, next question, how good is HTR? Well, the answer is, it depends. It depends on the document and the hand that it's written in. It depends on the HTR engine you're using. It depends on the model you're using and that fine training that you're doing, maybe on a particular hand. But most importantly, it depends on what you want to use the text for, right? Quality, really, some quality metrics may not apply at all for some uses, and for others, right, they're fantastic. So let's talk about quality metrics. Most automated transcription systems talk about something called CER, character error rate. The classic definition of CER measures the number of changes that need to be made to the computer's output to correct that text, right? So that's calculated by the number of inserted characters you have to do, the number of deleted characters you have to get rid of, and the number of substitutions, all divided by the total number of characters. So you're going to see CER numbers like 5% or 10% or 3% or 0.5%. Character error rate is not the same thing as word error rate. The average word in English is 4.7 characters long, so you'd kind of expect a 5% CER in English to result in a 23% word error rate. So 3 out of 4 words are likely to be correct if you're using a 5% CER model.
But that means one out of 4 is going to be wrong. Right.
Okay, so CER as a metric is not perfect. For one thing, not all errors are equal. So reading the name Renee as Renee with no accent has a CER of 20%. 1 character out of 5 was wrong. But so does reading Renee as numeral 8, NA, right? These are not really equivalent errors. Honestly, if we're doing a full text search, possibly going without the accent works fine, but definitely replacing the R with an 8 is not great. In addition to this, CER is a poor predictor of the amount of effort that it's going to take to correct a text. It's a lot easier to correct obvious errors than it is to find subtle errors. So there's a lot of alternative measures of error rates. One of them weighs substitution errors at 5 times the severity of insertions or deletions, just because they're so much harder to find. Okay, another difference. Because HTR and OCR tools match a word that's transcribed to the region of an image where it was written, which, as we said, is a wonderful feature for word highlighting and full text search. That also means, though, that they can produce the kinds of errors that we would not see in human transcribed text. People generally transcribe text in the order that they read it. The technical term for that in these engines is reading order. And humans might have some exceptions for footnotes or marginalia. HTR systems can slip up when they are analyzing the layout of a document. So they could interpret a two-column document as a single column, and that results in a unreadable text like this one, right? Reading all the way across these two columns produces something that doesn't make any sense. But let me point out that the character error rate of this unreadable text is 0, right? This has a perfect CER score. So you have to be careful with these kinds of metrics. Okay, I could nerd out about transcription errors all day long, but we kind of need to get back on track. So let's talk about HTR engines. So we are partnering with Transcribus, which is an HTR tool produced by the Reed Co-op. This is a group of universities, libraries, and archives, mostly in Europe. It's led by the University of Innsbruck. Over the past decade, they have advanced HTR technology for archival documents substantially. Transcribus offers thousands of different models trained by their users on their own documents with their own ground truth. You'll notice that in this example, that CER rate for these different documents, you can see that they expose that, and it's useful for choosing the appropriate model for the documents you're working with. Okay, so we've talked about HTR. So the great thing about HTR is it lets us replace humans with machines, right? Well, not so fast. So maybe we're biased, but Sarah and I run FromThePage, a web-based platform for manuscript transcription. So unlike HTR, we use crowdsourcing and collaboration to transcribe documents. So we've hosted hundreds of projects over the past few years, and our users have transcribed more than 2 million pages on the platform. So the question is, if HTR technology exists, why might the library and archives that we host want to keep human transcription? So for one thing, humans are more accurate than machines. They can learn from context and develop expertise on a particular hand or a particular subject. Better than that, though, they can collaborate. Like in this example from the British National Archives, where volunteers are helping each other decipher a name, and one of the people is actually looking at the Old Bailey online to isolate exactly who this person might be. Another benefit is collaboration, right? And all the collaboration provides this benefit of public engagement. So the Riksarkivet, the Swedish National Archives, has drawn 318 people to volunteer on I Demokratens namn, transcribing women's petitions for the right to vote. So these are people who might not interact with the Riksarkivet normally, and now they have a connection to the institution and to its holdings. Finally, transcribing documents provides meaningful volunteer work to people who are elderly, homebound, retired, and I just wanted to illustrate that with some quotes from Tom York, who is a volunteer who spends several hours a day working on projects at the Indiana State Archives. Since 2018, he's transcribed 77,000 pages. He's very active, he's very dedicated, and this provides a really important part of his day. So HTR presents a challenge to us. If we don't want to replace humans, can we use HTR technology in a way that increases our users' accuracy and enjoyment and productivity? So let's talk about the principles that we wanted to follow for integrating AI into crowdsourced transcription. We want AI functionality to be optional instead of required. We want AI-generated data to be transparent to users rather than invisible to them. And we want that data to seem tentative instead of authoritative. So here's how we're trying to use HTR to help transcribers working with historic documents. So it all starts with a page image. So this is a test that's done with the 1883 Diary of Emily Craig, which is held at the State Library of New South Wales. These images were imported into FromThePage using IIIF, but they could have been uploaded as PDF or images. So we take the URI for that page image and we submit it to the Transcribus processing API. That lets us specify a model ID, In this case, we're using the Text Titan 1 model, which is a transformer-based model that's pretty good for general purpose Western scripts. So we then poll Transcribus to see when the processing is finished, and we fetch the HTR text as alto XML. As you can see, that's got all those bounding boxes in it. It's also not something you'd ever want a human to edit. So the next step is to present that text to our users as they're transcribing a document. So our transcription screen is pretty simple. The image viewer appears on one side, the text area is on another. Where are we going to stick this complicated XML document? Well, let's take a closer look at that image viewer. We've added a new button on the upper corner of the viewer. So we're calling it AI Assist in our English language interface, but French, German, and Spanish have some variation of like AI Assistant or something like that. So clicking that AI Assist button takes that Alto XML and paints the text onto the image as a text overlay, letting users see what Transcribus thinks the text is in the context, right next to those bounding boxes of where that text was found. I have to say, whenever I demo this, this is where we usually hear kind of gasps from librarians and archivists. The output is really impressive. So the text scales with the image viewer, so users can zoom in and pan the image to see a word that they're having trouble reading. So in this case, I've been transcribing the document and I come across a word that doesn't make a lot of sense to me. I can zoom in on the word and request an AI assist, and then I see Transcribus has identified the word as station, which is an Australian term for what we here in Texas would call a ranch. So users can also lock the image to display, to select text to copy and paste into the editor. So copying and pasting can work, but it's kind of slow, right? So the next question we were addressing is, could we use the text from Transcribus as a first draft for our transcribers to use? So to work on that, and again, privileging this whole AI being optional principle, we added a new AI text button to our transcription interface. If people decide to use it, it should pull in HTR text for them to edit as a first draft. So how does that work? First, we need to convert the Alto XML into the kind of wiki text that our transcribers prefer. That's a pretty straightforward process. But the text has a lot of errors. We don't want the process of correction to be more difficult than necessary. So we want to highlight the errors so that users can focus on them. So the first step in that process is to ask ChatGPT to normalize the text. We tell it to be a scholarly editor preparing historic documents for publication. Then we feed ChatGPT the raw HTR text with this prompt, in which we ask the large language model to correct any errors produced by the automated process. So that does a very nice job of producing a readable version of the HTR text, right? So most of it makes sense, and ChatGPT knows not to correct personal names, so that's pretty cool. There's just one problem with ChatGPT's corrections. They are absolutely poisonous. The corrections are not based on a better reading of the image or better knowledge of the people or places mentioned in the document, right? They're based on nothing. They are plausible, but wrong. We want to treat AI-produced text like this as radioactive. We never want to show this to users. Far better to show them the raw HTR text with its obvious errors. So how can we use this poisonous text? So the corrections produced by ChatGPT are worthless, but knowing what ChatGPT thought should be corrected, that's valuable. We also want our users to view AI-produced text with skepticism and to be critical about it. What we decided to do was compare the ChatGPT corrected text with the raw HTR text produced by Transcribus. Anytime the texts are different, that's when ChatGPT tried to correct something, we replace the text with a puzzled face emoji. So our goal is to make this AI-produced text look as unauthoritative as possible so that users feel comfortable editing it. We also added a warning to the beginning of the text. So users have to delete that as they edit, right? We want the human intervention to happen as much as possible. So this is what a transcriber sees when they request AI text as they work. Our goal is to force them to consult the image as much as is necessary to get a good transcription, while at the same time helping them with the readings that are probably accurate. So how's it going? At the moment, our friends at the State Library of New South Wales are testing the usability of this feature. In addition, we've had help from the Center for Archival Futures at the University of Maryland, and we'll talk about that in a minute. What we're testing for this, we're testing some differences in workflow. Should we start users with the HTR text and have them corrected, or should we make the AI text optional at the kind of the flow that we demonstrated earlier? Another question that we're testing is the differences in the kind of text we show to users. Do people prefer the raw HTR text, which some people have said they like, or do they prefer the placeholder approach? If they prefer these puzzle face placeholders, should those placeholders be at the character level, or should we replace any word that contains differences so that people are forced to go back and look at the original image?
And is the emoji the right placeholder?
Yeah, that's another question,
Yeah.
right? So we hope to evaluate the testing on the basis of transcriber enjoyment, right? How pleasant is this? How annoying is this? We also care about engagement with the task. How much time are people spending? Are they getting bored, right? Do they hate this process, which oftentimes has been the case with OCR correction processes? We want to look at volunteer productivity and, most important, the accuracy of the results compared with ground truth from pure crowdsourced transcription projects. So we received some early findings. We're about halfway through our user testing, maybe a third of the way through. And we particularly like to thank the students at the Design, Cultures, and Creativity Honors Program at the University of Maryland for their impressive work on this. And also Victoria Van Heining for
Their professor.
Yes, for bringing that class there. So what did they find? Students in general prefer using the AI text flow. They liked having a draft of the text to edit. They liked that they had control over using it or not. They also found that it helped, having kind of the AI transcription, helped them understand the contents of a letter before they transcribe it. They were not as happy with the emoji placeholders. So I'm kind of puzzled by that. So what are the next steps? Once we have the results of this testing, we plan to fully integrate the Transcribus HTR engine into the FromThePage user interface. So that would allow project owners to enter their Transcribus credentials, select a model or type in a model ID from that list of models you saw earlier, right, and then process their documents. We also hope to use the bounding boxes in the Alto XML files, which are produced by Transcribus, and then merge in the corrected transcription so that you can get corrected OCR. So hopefully you get the benefit of all those bounding boxes, but with text that actually is correct. Finally, we also are planning to explore additional HTR services on top of Transcribus. Transcribus is very, very high quality, but it's a little pricey. Lower cost alternatives might be useful for some kinds of applications like summarization or language detection.
We are also looking for some partners to work with us to do more of this testing. And I'll have a slide towards the end that's a little bit more about that.
So let's wrap this up with some fun stuff we encountered during the process. So anyone who's used OCR will be familiar with the gibberish that it produces when it encounters, that's fine,
Okay.
ink bleed through. So generally that's like a string of random punctuation marks. When you feed bad images with ink bleed through like this to Transcribus's text Titan model, you don't get gibberish like that. You get brief phrases in French or German, probably because it was trained on so many European documents. So If you're wondering why you encounter occasional phrases in German in a diary kept by a Victorian era Australian lady, this is why. It's probably gibberish. The page is probably blank. So we ran into another hallucination when we accidentally asked ChatGPT to correct pages that were blank. Okay, in those cases, it always produced exactly the same text, which is a wild letter from a researcher who claims to have discovered lost writings from the American Revolution that are written in code and will revolutionize our understanding of how the American Revolution worked.
Doesn't this sound like that Nicolas Cage movie?
Yeah, I mean, it's straight out of
Yeah.
a conspiracy theory. So this is kind of an amazing hallucination. I was astonished. Like we really had to track down what was going on until we finally figured out, oh, we asked it to correct something that was blank, and here's what it generated.
So we are looking for more feedback on this feature. We're looking for 10 partners who are willing to work with us for 6 months and give us feedback and work with transcribers and their material to figure out which of these options work right. You know, which placeholder replacement is the right one to use. You know, how many of these options and these widgets should we be providing people? Are we doing too much? Is it too confusing? Those types of questions, we know that we need people beyond fundamentally the two of us to figure out. So we're looking for development partners to work with us, and kind of the details are here. We'll put them in the email that goes out after this webinar. But I think it's a pretty cool opportunity because not only are you getting a half-year subscription to FromThePage, but you also get access to these HTR models, which have costs, right?
Yeah.
So please email me. We'll drop that email in into the chat as well. Yeah, so I'm looking for, I'd love for people who can work with us. There's a question in the chat about when does it start? Starting around April 1st, so pretty soon, and running for about 6 months. But if I don't find my 10 partners by April 1st, then I'll probably be willing to take people after that.
So that is the end of our presentation. So I'm going to stop sharing and open up the floor for questions. Because we have so many people on the call, at least initially, I would like to have people ask any questions in the chat.
So Paul is asking about partners from elder care homes or people who have free time and maybe want, purpose and task. So we love volunteer transcribers like that. They usually do great, high quality work. They are, would be welcome to work on some of the projects, but I'm looking for institutional project partners who can kind of run the projects with us. But your people in elder care homes would be more than welcome to work on these projects or any other project on FromThePage.
Any other questions?
You can also do a live demo, but we'll give it some time for some questions.
Yeah. What format do the records have to be in? We can handle images, so zipped up JPEGs or PNGs. We can handle PDFs or material that's already in image service platforms and digital library systems.
Yeah, TIFFs too.
Another question, are we using AI to help pull out names to make an index?
We have done some experiments on that, and we can paste in our AI webinar playlist. And if you go look at was 10 ways AI is going to change archives, that one is where we kind of document some of those experiments. There's so much this technology can do, and we are so excited about it, but this one is the one that makes the most sense for FromThePage to start with. So maybe eventually is the answer there. One thing at a time. We're a pretty small shop.
So Laura asks how you can try AI Assist in current collections.
Right.
Send email to Sarah.
Well, we have a sandbox that people can play with. There's a handful of documents that we'll probably send out. We'll send this out eventually. Where's Ben got? Okay, yeah, Ben's gonna share his screen and we'll drop. Maybe do the okay.
Yeah, so Group chat.
Toby asked about TIFFs. Yes, we can convert TIFFs.
Can institutions ingest the transcriptions into their own systems at the end of the project? Yes. So we support about half a dozen different export formats, from PDF and Microsoft Word to plain text. The only thing that
TEI-XML,
right.
like everything.
The only thing that we don't support yet is this kind of reverse mapping onto Alto XML. That's something that we're hoping to develop. How many records are we looking for? Do we want the collection to be written by the same author or a variety? I'm actually pretty keen on getting a variety of people, and here's why. Traditionally, HTR projects have been run with the assumption that they want to get as accurate a computer-generated transcription as possible. To minimize the amount of correction to be done, because correcting is so hard, especially with the bounding boxes and stuff. And as a result, a lot of the effort that's been done by scholars, digital humanists, technologists who are working with these HTR tools focuses on getting a collection that's all in one hand and training it on maybe 100 pages, transcribing it using something like Transcribus, and then correcting and retraining and fine-tuning that model. That's not really the environment that we're talking about, right? We've got a pretty good correction platform for people to collaborate to correct these things. So I think that there are opportunities to apply HTR technology to get a lower character error rate on documents that you're planning on having humans go through and edit anyway. And so a heterogeneous collection of documents, I think that we have the potential to be able to use HTR with that in ways that HTR only systems might not.
The follow-up question here from Atiba at the German Historical Institute, I think is a good one too. Can we use it on any other Transcribus model, or are we just using text Titan English language one?
Yeah, you specify whatever model you want. We handle anything that's in Unicode. The only things that we have trouble with are top to bottom scripts, particularly older Chinese and Japanese. But left to right, right to left, that all works.
German, yes, no problem.
Yes, German works, yes.
So yeah, you would have to figure out which model you want to use in Transcribus.
Right. Is this written out somewhere we could send?
Yes, Terry, I'll send you, I've got kind of a stock email about the partnership program, and I'm happy to send it to you and anybody else here who would like it.
Are we planning to support the ability to push corrections back to Transcribus or other HTR projects for use in refining models, or is this ingest only?
I made Ben take out that bit of
yes, that's right. Yes, actually, we've had the ability to produce Transcribus training data for a little over a year now. The challenge is that currently those exports are in plain text files that are in the format that the Transcribus text to image tool expects. And the text to image tool has been offline since last March because they are rewriting it. That said, the Transcribus folks expect to have that up and running again first or second quarter of this year. So we would love to see some round trip integrations there of corrections, training, HTR application, correction, training. Like let's see how that all works, because that could be really fun.
It'll take a little bit of manual labor on your part, right? Just to get all the pieces in the right places, but we're happy to work with you on that. Okay, wait, I got some more people. I can check the chat later to
be
make
able
sure.
to use a model that you've been developing in Transcribus already. Sure, so long as you have the model ID and you know the and it is accessible to your account via the API, which I think should be all of them, that would work fine. Yeah. Okay.
I'm getting all this written down and we'll check the chat later.
Okay. Can we add this to the email that's going out after we wrap up? Yes, we will write that up there. We've got a couple more people who are joining late.
Kind of like, but okay.
Yes. Any other questions or suggestions? Oh, what about, here's one that I missed. Do we prefer form data or can we work with collections that have various types of textual documents? Okay, let's talk about that for a minute. So form data, so we demonstrated two different ways of using HTR text from the page. One of them is the text overlay on the image viewer. That should work for all projects. The other way of using this is the AI text for a draft. That is only going to be accessible, at least right now, for document-based transcription projects. So the projects that we host that are field-based or spreadsheet-based, we don't have any way now of parsing those Alto files and figuring out how to map them onto fields. It might be something we're interested in exploring once we get the kinks worked out and kind of the most common use case.
The easier use case.
Yes. All right. Any other questions or comments?
I also had a question about bilingual texts. I'm in Canada and I operate in a bilingual environment.
Right.
And sometimes it goes from French to English and English to French. And so it's not necessarily like I've had some very funny experiences with Teams when it tries to transcribe stuff, hallucinations to the nth degree when it moves to French.
Yes.
So I'm just curious what if there's that ability of like language recognition, or do you absolutely have to identify what language it is before you do the HTR?
Text Titan, so the generic Transcribus model that we used in all the demonstrations today. It's the one that hallucinates in German, right?
And French.
And
yes.
French. It might work, just work.
Yes.
I don't know.
So what we've observed is that Transcribus has two families of models. They're traditional models that are trained on one hand. And one of the typical use case we've seen is somebody who's working with maybe 5,000 pages worth of archival text. And they will fine tune their model as they're transcribing and correcting that text. One presentation I saw a couple of weeks ago was as many as 16 times, right? So those are not general purpose. They are very much location and hand specific.
But they're trying to get their character error rate really, really, really low
Right.
because they don't want to have people correct things.
So
Right.
Transcribus has just released these new transformer-based models, what they call supermodels. So there's Text Titan, one that they just released is Dutch Demeter. They are generally, rather than focused on a particular hand, they can handle multiple languages in similar scripts across different regions and different centuries. So the Text Titan that we use for our processing is good for 16th century onward, Western European Latin scripts. So don't try it on Hebrew, don't try it on Cyrillic, but it should work fine for 19th and 20th century Canadian documents in French and English.
Although I would love to see it as a test bed, because can it, like, at what level of discretion is it good at, right? One document versus another, sure. One page versus another, maybe, sure. Going back and forth between the two languages in a single page or a single sentence, who knows? It'd be really interesting to find out.
There's a question about mathematical text. We've not done any tests at all with HTR and mathematical symbols. We support, and from the page, manual encoding using LaTeX for chemistry and mathematical formulas.
Also, anything you can type in Unicode.
Yeah, but we have not looked at all at how that might work with HTR. Any other comments or questions? No. Well, thank you all for attending. we really appreciate all the questions. And material and tables or lists. Yeah, again, we can use the HTR.
Lists work pretty
Image.
well, but
Yeah, lists
things that
lists are
look
good.
like spreadsheets are just so much harder because we have a way to do that, and we don't have a way to map machine generated text onto our spreadsheet format.
So thanks everybody for coming.
Thank you.